Okay, you've already done 6.1b as far as the length of an arc. Now we're going to do the area of a section of the circle. Area of a sector. So given a circle, and let's just do something simple. Let's just do this little portion. This is a 90-degree angle, and this is 1/4 of the circle that is colored in. And area of a circle is pi r squared. Okay, now let's just talk about how much of a circle that we have here. If we say this is 1/4, how did we get that? Well, this is 90 degrees out of 360 degrees that we've already taken around the circle. Well, 90 over 360 is 1/4. So how you find the area of a sector, or the portion that you're wanting to know, is it's really the angle or the part that you're looking at divided by the whole. The part, which in this case was 90, divided by 360. And since we're dealing in radian measure, we're going to say that this is theta, however much theta is in radian measure. Since we're dealing with radians, we want it in theta, divided by the whole circle. The whole circle is 360. That is actually 2 pi in radian measure. So the portion that we want to find, the part that's shaded in, is going to be theta over 2 pi. Alright, so if we take theta over 2 pi, now let's just talk about this piece again real quickly before we do this. If I want to know how much of this, in general and common sense terms that we're looking at, how much of this is shaded, you'd say this is 1/4 of the whole area. So you would say that's 1/4 of pi r squared. Well, the 1/4, how did we get that? By the part divided by the whole. Again, since we're going to be talking about radian measurement, that 1/4 is the same thing as saying theta over 2 pi. So instead of saying 1/4 and only saying 90 degrees, no matter how many degrees we have, we'll use this little conversion. Theta over 2 pi, that'll be in this position, times pi r squared. Notice then at this point that the pi's cancel out, and what we really have here, that's a coefficient of 1/2 times theta times r squared. And that is how we find the area of a sector of a circle. And again, theta, we're going to be converting to radian measure, and the way we've been doing that is pi over 180. So let's do an example and figure out how much of an area of a circle we have. So I'm going to read an example out of the book, and we'll do something from there. So number 62 I'm going to look at. If you have your books open, find the radius of each circle if the area of the sector is 12. Okay, so now they're giving us the area is 12. We want to know what the radius is. So here's the picture. The first picture looks like this. And they say that this is 7 radians. Notice that they've already got it in radian measurement for us, so now we don't even have to convert it. So if I want to know what this radius is here, all I have to do is plug this information in and solve it. So 12 equals 1/2 times 7 times r squared. So let's multiply both sides by 2 to get rid of the 1/2. So 24 equals 7r squared. And then divide by 7. So r squared is 24/7. And in that case, that is, and then you're going to take the square root of it. I'm sorry, this is 0.7 in the book. Let's make sure this is right. It does say 0.7. So 0.7. So we're going to divide by 0.7. And then to get r from r squared, we take the square root of whatever that is. So again, in your calculator, take 24 divided by 0.7, and r is approximately 5.86. Alright, and that's the first example. Again, let's make sure we understand what we're doing. They gave us the area of this section, and we wanted to find the radius, so all we did was plug in information. All right, let's do another example. That was kind of rough. Do another one. That was example 62 part A. Let's do part B. Here they give us the degree as 150 degrees, and we still want to find the radius, and the area is still 12. Again, area equals 1/2 theta r squared. Area is 12. Theta, we got to convert from 150 degrees. So you need to take 150 times pi over 180. Everybody now should have that memorized, how to do that, times r squared. So we divide that out, reduce it down, and multiply both sides by 2 to get rid of the fraction. We get 24 equals r squared times 2.618. Now we're going to divide by the 2.618 and take the square root of that to get r. R is approximately then 3.03. So I know this is we're going through this fast. You need to have your calculators out as we're doing it and kind of type it in to make sure that you get the same thing. You can pause the video at any point in time and try to catch up and see how we do each of these. So that's how you find the radius given the area. So let's do an example where we're going to try to find the actual area and just plug in all the other information. Anything you have. So area 1/2 theta r squared. So as long as we have 2 of these 3 variables, we ought to be able to find any of the others. Let's do, let me pick one out here. Find the area of the sector with central angle of 1 radian and a circle of radius 10 meters. So 1 radian, let's just say it's like this, 1 radian. And our radius is 10 meters. So let's just act like we don't know how big 1 radian is, and we just draw it up there just for just to make it look like we know what we're doing. Let's find out what the area is and see what happens, and then we could probably draw a better model. So the area is 1/2 theta in terms of radians, which is already there, 1 times the radius squared. So here we have A equals 1/2 times 100. A equals 50. The area is 50. In this case, is going to be meters squared. It is in meters, and that is true. Okay. So meters here is 50 meters squared. Excellent. Not a problem there. If you want to know how many degrees that is, you should be able to tell that. Converting radians back into degrees, you would take 1 times 180 divided by 3.14. 180 divided by 3 is 60, so it's going to be roughly close to 60 degrees. Not too far off from there, maybe about that much. That's what it would look like if you really wanted to find out how much of the circle was shaded in. Okay, that is how you find area, that's how you find radius. Let me see if there's an example here where we can find the degree. If we need to, we shouldn't really need to at this point. You're just solving stuff at that point. Yeah, I think we're good at this point. So you need to add to your homework assignment. The homework assignment was 51 to 59. Add to that all the way to 77. So page 440, 51 to 77 odds. So the first part of this was finding the length of the arc. The second part is finding the area of the sector of the circle. All right.